Jai Hind everyone, myself Sandeep Yadav, Assistant Professor CSC Department. Today I am going to deliver a guest lecture on transaction processing. This is a part of DBMS being taught to 5th semester student of BTech in UPTU whose course code is BCS 501. This topic relates to unit number 4th. As we know that transaction is a collection of operations to perform a logical unit of work. In day-to-day life, we hear a lot about transactions. For example, banking transactions, which involves transferring amount from one account to another account, or just we are having reading the balance. That is also example of transactions. So, following the topics that we are going to discuss in today's lecture, first is transaction, second is the property of the transactions, that is asset properties of the transaction, third is the transaction state diagram, fourth is the schedule. So, first of all we shall be studying what is transaction. So, what is transaction? A transaction is a collection of operations or a sequence of operations that is performed as a single logical unit of work. It is a unit of work that contains one or more SQL statement in form of read and write operations. So, read operations basically read the value from the disk, and write operation performs the manipulation on that particular data item and transfers the updated value back to the disk from the buffer. Let us consider an example of a transaction. Now, first we are reading the value of A from disk. Where the value is present? The value is being presented disk. Then we are deducting 50 rupees from A. Then we write A equal to A minus 50. Thereafter, after updating the value of A, we write A, means the value has to be now updated into the disk. The value is still present in buffer. Next, read B. Now we will be bringing the value of B from the disk into the buffer, that is accomplished by read B. Thereafter, B equal to B plus A, that is we are adding 50 to the current content of the B. Then we are writing it, and finally we write B, that is the value of B has been updated. Now we have to update it into the disk. So, these are the operations that we are performing. So, whole of these operations combined together perform a single logical unit of work. That is the main purpose of the transaction. So, this is the main purpose that we have done. Next, asset properties of the transactions. So, first is atomicity, which ensures that either the transaction executes 0% or 100%, means either all the operations are successful or none are. Suppose we transfer 100 rupees from account A to account B. Now, money has been transferred from account A, but the money has not been transferred to account B. So, what should we do? But it has not reached B. Then it is not successful because the half of the money is still residing, half of the money still has not reached the B, means it has half of the operation has been successful, that the money has been transferred from A, but it has not reached B. So, that is still a failure. So, either it should be 100% complete or it should be 0%, that is in digital form we can say either it is 0 or 1. So either all the operations shall be successful or none are. That is, next C stand for consistency. That is, the database must remain in consistent state after the transaction as it was before the transaction. Next is isolation. That is, in serial execution only one transaction runs at a moment of time. That is, only one is running. After the completion of one, another transaction will run, and so on. So there is no interference among the transactions, as only one is executing at particular moment of time. But when several transactions are running at one moment of time, we need to maintain the isolation property of the transactions, so that no interference takes place between the transactions that are running parallelly to each other. That is, intermediate transactions results must be hidden from another transactions that are currently executing. Third is durability. Durability means once the transaction has completed successfully, the result should be updated in the disk permanently. That is, the results, whatever the results are there, they must be reflected in the disk permanently. That durability means everlasting, long lasting. So here the terminology means that the changes must be reflected in the disk permanently. Only then we can say the property of durability has been maintained. So in a nutshell, in simple word ACID, we can define all the properties. ACID, the ACID is a keyword to define the properties of the transactions, and it is generally asked in various type of examinations. See, all of us must remember this keyword ACID. Now first of all, we are seeing atomicity. It states that a transaction must be treated as a single atomic unit. That is, either all of operations are executed or none are. The transaction execute 0% or 100%. That is, either 0 or 1. For example, consider a transaction to transfer rupees 50 from account A to account B. Then we will be writing transaction in this type: read A equal to A minus 50, write A, read B equal to B plus 50, write B. Now after the last line is executed, we say the transaction has partially committed, that is, it is over. Now if 50 rupees is deducted from A, then it must be added to B. Next is consistency property. Let us celebrate it. The database must remain in consistent state after the transaction as it was before the transaction. That is, the total must remain same before the transaction and after the execution of the transaction. Okay. The total must remain before the transaction and after the transaction. Now let us see the example. A equal to A plus 50. Suppose initially A is 1000 and B is 2000. So the sum of A and B is 3000. Now after performing this operation, then the value of A is 950 and B is 2050. So after the completion of write B operation, what shall be the final value? That is 2050 of B and A is 950. Now we are seeing that the total value after the transaction and before the transaction. Before the transaction, the total value of A and B was 3000, and after the transaction, the total value of A and B is 3000. That is, the total remains same. That is, the transaction is in correct state. This is known as the property of consistency, which every transition is supposed to maintain. Next is the isolation property, that is, changes occurring in a particular transition will not be possible to another transition until it has committed. Intermediate results will be hidden from other transitions that are working parallelly, so that they do not interfere in each other state. This is particularly very important when several transitions run at particular moment of time. Otherwise, it is of no concern when serial execution takes place, because at that particular moment of time only one transition shall be running at that time. So, there are no other transitions to interfere in its working, but it is critical to maintain this isolation property where several transitions are running at same moment of time. For example, once our transition start from first step, its result should not be accessible by another transitions until the last step, that is, last step was write B. It is completed. When the last step completes, the result, final results, that is the final value of A and B should be visible to other transitions. It should not be visible to other transitions before that. Start A equal to read A equal to A minus 50, that is, we are writing the value of A, then write A, thereafter we cannot see the value of A here, it is clearly forbidden. A of value we cannot see, right? Then read B equal to B plus 50, write B. Now, after the completion of last line, the result can be visible to other transitions, but in between these nodes should not be visible. That is the property of isolation, that is, intermediate results must be hidden from other transitions. Next is the durability. After a transition completes, the changes it has made to database persist, that is, they remain permanent even if there are system failures. Once our transition complete up to the last step, then result must be stored permanently. It should not be removed even if the system fails. That is, let us see that transitions A equal to 500, B equal to 500. Now, we are transferring 50 rupees from A to 50 to B. So, A will be A minus 50 and B will be B minus 50. So, what will happen? The final value of A is 450 and the final value of B is 550. Now, these value, when the last line executes, that is, write B executes, then these value must be stored permanently in the database. That is the property of durability. So, the changed value must be reflected back in the disk. Only then we say that the property of durability has been maintained. I hope it is clear. Next, the various states, that is, transition state diagram or transition diagram. Now, we may have previously studied in also in DB in operating system that a process undergoes several states during course of its completion. In the similar fashion, transition has also several states during its completion. So, let us see each of them one by one. Now, first state is active state. As soon as the first line of transition start, that is read A start, we say the transition is in active state. So, active state is the initial state in which the transition remains till it completes the execution. Till write B, it will be in active state. So, active state will start from here end will end till write B. So the working active state is the working state. Thereafter, now when the last line completes, we say write B complete, we say the transaction has partially executed. When the last line execute, that is write B execute, after that we say the transaction has partially committed, means the operations are successful, but the values still are not written in the disk. Now after the partially committed state, next state will be committed state, that is the transaction enter in this state after the successful completion of the transaction. We cannot abort or roll back a committed transactions. The committed means the changed values of A and B are reflected in the disk. When the changed values are reflected in the disk, then we say the transaction has committed. Next is failed state. So a transaction may enter in failed state from an active state due to the various type of failures that occurs either on part of transactions or part of operating system, or due to any hardware failure, or due to the problem faced by the DBMS. During the failed state, we discover that transaction can no longer proceed. So once the transaction cannot be completed, any change it has done must be undone by rollbacking it. Suppose it has changed some values, then we will be retrieving the old values. Now in our example we see, if after completing write A the transaction fails, then what we will doing? The changed value of A must be reflected back to the previous value, that is now the value has become 450, it must be changed back again to 500 because the failure has occurred. Now the failure may be due to a variety of reasons. After the failure comes the aborted state. The state after the transaction has been rolled back and the database has been restored to a previous state prior to the completion of the transaction is the aborted state. So the transaction will end in two ways, either it will be successful or it will be completed state. So in failed state, a transaction can come from active state directly to the failed state or from partially committed state to failed state. It can be also there. So anyway, the transaction will be ending in two ways, either it is committing or it is aborting. Only there shall be two way. The transaction will end either successfully or unsuccessfully. If it is successful, then it is committed state, and if it is not successful, then it is aborted state. So let us have the quick recap of the transition state diagram. Active state, it is the initial state and the transition state in this stage in this state while it is executed. Partially committed, when a transition completes its final operations or the instructions, it is partially committed. Failed state, when we discover that no longer a normal execution can proceed, then it is failed state. Once a transition cannot be completed, any change it made must be rolled back. Committed state, the transition enter in this state after the successful completion, that is the value are reflected back in the disk, then that is committed state. Next is we cannot roll back or abort a committed transactions. That is for sure. Once it has committed, we cannot roll back the values, the changed values. And the last is aborted state. The state after the transaction has been rolled back and the database has been restored to its previous state as it was before the start of transaction. That is the aborted state. So that is in nutshell all the states of the transitions that we have explained. I hope it is clear to everyone. Jai Hind.